Week 6 homework is on capacitance in AC. Let's go through that homework now. Number 1, can current flow through a capacitor? No, it cannot. It appears that current flows through a capacitor, but no current actually flows through it. If current flows through a capacitor, that's leakage current, and that means the capacitor is bad. Number 2, what two factors determine the capacitive reactance of a capacitor? The two factors are frequency and the capacitance of the capacitor. We have the formula capacitive reactance equals 1 over 2 pi fc. 2 is a constant, pi is a constant, F is frequency of the applied voltage, and C is capacitance of the capacitor. Number 3, how many degrees are the current and voltage out of phase in a pure capacitive circuit? 90 degrees out of phase. And number 4 shows it. What does the current in a pure capacitive circuit, does the current in a pure capacitive circuit lead or lag the applied voltage? So here we have the applied voltage, and here we have the current flowing through the circuit. And we can see at time 0, or at 0 degrees, the current is at its maximum and the applied voltage is at 0. As time moves on, we can see that the current is actually leading the voltage by 90 degrees. So at 90 degrees, current is at 0 and applied voltage then reaches its maximum. At 180 degrees, current is at its negative peak while voltage is at 0. At 270 degrees, current is back up to 0 and voltage is 90 degrees behind, and it finally reached its negative peak, and so on. Number 5, a 30 microfarad capacitor is connected to a 240 volt 60 Hertz circuit. What is the current flow in this circuit? So first we need to calculate the capacitive reactance. That's the current limiting effect of a capacitor. And that formula we saw earlier. Capacitive reactance equals 1 over 2 pi fc. That's this formula shown here. And it yields 88.419 ohms. Then we can use, here I'm using Ohm's law. So 240 volts divided by that 88.419 ohms gives 2.714 amps. Number 6, a capacitor is connected into a 1250 volt 1000 Hertz circuit. The current flow is 80 amps. What is the capacitance of the capacitor? So we can calculate the capacitive reactance using Ohm's law here. That's step number 2. And then if we take the formula that we know very well, we need to solve for capacitance. So by doing the algebra, we get capacitance equals 1 over 2 pi f x sub c, or capacitive reactance. That's this step here, and it gives an answer of 10.186 microfarads, or 10.2 microfarads. Number 7. A capacitor is to be connected into a 480 volt 60 Hertz line if the capacitor has a voltage rating of 600 volts DC. Will the voltage rating of the capacitor be exceeded? It will be. So here's how we figure it out. So the capacitor's voltage rating is given in volts DC. The peak value of the applied voltage of this 480 volts AC, the peak voltage of that 480 volts is the DC voltage rating. So some chapters ago and some weeks ago we talked about this, but to calculate the peak value of 480 volts AC, which is the RMS value, we use this formula here. V peak equals VRMS times 1.414. And if we plug in the values, we get the peak value is 678.7 volts. That 678 is greater than the 600 volt DC rating of the capacitor. So yes, the voltage rating will be exceeded. On average, by what factor is the life expectancy of a capacitor increased if the capacitor is operated at half its voltage rating? This comes straight from the book, and it's 8 times. Number 9. A capacitor is connected into a 277 volt 400 Hertz circuit. The circuit current is 12 amps. What is the capacitance of the capacitor? This is very similar to what we saw in an earlier question. So we use Ohm's law to figure out the capacitive reactance. That's this step here. And that equals 23.083 ohms. Sorry for my bad writing. And then using this formula here, we saw the algebra for that earlier, but I'm just going to write it a little bit bigger. Capacitance equals 1 over 2 pi times capacitive reactance. If we plug in the numbers that we determined and that were given, that's step 4 here, we're given, or that yields, a capacitance of 17.237 microfarads. Number 10, a capacitor has a voltage rating of 350 volts AC. Can this capacitor be connected into a 450 volt DC circuit without exceeding the voltage rating of the capacitor? Yes, it can be. So very similar to what we saw earlier. Because the capacitor's voltage rating is given in AC voltage, the peak value of the applied AC voltage is equivalent to the DC voltage. So again, to calculate the peak value of the 350 volt AC voltage rating, we use V peak equals VRMS times 1.414, and we get 494.9 volts. That's the voltage rating in DC. The peak value of that AC voltage is the equivalent DC rating. So the rating of the capacitor is 494, it's a 450 volt DC circuit, so yes, we can use that capacitor without exceeding the voltage rating. Number 11, a utility company plans to connect a total of 4 20 microfarad capacitors into a 7200 volt line. To make this connection, 4 capacitors will be connected in series. What is the capacitance of each capacitor? So, total capacitance in a series circuit, we simply add up the capacitances of the individual capacitors. Because all 4 are the same value of 20 microfarad, and we know that there are 4, we can simply multiply the capacitance times the number of capacitors, or 20 microfarads times 4 capacitors, and that gives a total capacitance of 80 microfarads. Number 12, what is the minimum AC voltage rating of each capacitor in the previous question? So all the capacitors have the same value. So the voltage across each capacitor is the same. So we can use very simple math. We have a total of 7200 volts divided by the 4 capacitors, and so each capacitor has to have a voltage rating at least 1800 volts AC. So number 13 is asking what the current flow is through that previous question. So first we need to determine capacitor reactance. That's the current limiting effect, and we know that formula that's given here again. If we do the math by using the values that were given in the previous question, we get a capacitive reactance of 136.6 ohms. Now we can use that value in Ohm's law to determine current flow, and that's this step here, step 5. So current flow equals voltage divided by capacitive reactance equals 7200 volts divided by 136.6 ohms, and that gives 52.3 amps of current. And finally, number 14. What is the minimum kilovolt amp reactive rating of each capacitor in that previous question? And we're going to round off to the nearest kbar, or kilovolt amp reactive. So we know from the previous steps that we have 54.288 amps of current flowing through the capacitors. Each capacitor has 1800 volts of voltage drop across it. So if we do that math, this is just the power formula, we get 97,718 bars. We're going to round up to the next nearest kbar, so that's 98 kbars.